So 1 minute. Let it start. Yeah. So good morning all. Till yesterday's lecture, I have completed 2 units. Today we shall be beginning with the third unit, which is based on titration, complexometric titration and redox titration. All the basic of complexometric redox is there in this chapter. Especially redox, no one will explain you. No one. It is such a beautiful unit. But if you understand, you will enjoy. Otherwise, you will have to only by heart and reproduce in your paper. It will be of no use later on. You please attend lectures and try to understand. Redox is a bit difficult to understand, but once you understand, it will be in your brain lifelong. Today we shall start with complexometric titrations. Is it fine with everyone? Shall we start with complexometric titrations?
Yes, ma'am.
Okay, why others are muted? When I ask, everyone should answer. All your act is I am keeping an eye on everything. Who is answering, who is not answering, everything will be considered in the end. Please try to understand and be serious. Okay. So I hope my board is visible. Right. Is the corner part visible? Okay. So today we shall be starting with complexometric titrations. Till now, till SYBSC, you have seen acid-base titrations. Who will tell me what are acid-base titrations? Wait, I will only ask. Babita, unmute. Babita, unmute and tell me what are acid-base titrations? Oh my God, she was there. I saw her. Babita is not there. Oh, she left. Ahe, where are you? Okay, tell me, Babita, what are acid-base titrations? What are acid-base titrations? See, everyone SYBSC students, please listen and understand. Acid-base titrations are titrations in which you titrate an acid against a base, or you will titrate a base against the acid. I repeat, you can take acid or a base in the burette. If you take base in the burette, acid will be in the conical flask. If you take acid in the burette, base will be in conical flask. So when you titrate an acid against the base, the type of titration is acid-base titration. Is it clear? Indicators will be different for acid-base. For acid-base titration, can anyone tell me the indicators? Akansha, unmute. Akansha, please unmute.
Yes.
Yes. What indicators are used for acid-base? Name few indicators. Can you tell me at least one indicator?
Phenolphthalein.
Yeah, phenolphthalein. So the indicators used for acid-base titration may be phenolphthalein. You can have methyl orange, methyl red, thymophthalate. They are used only in acid-base titration. Please, now it is a. Oh, is my voice not clear? Is my voice not clear? आवाज बराबर आ रही है?
नहीं.
नहीं मतलब what is happening? Wait. अभी आ रहा है? Is my voice now clear?
हाँ मैम अभी आ रहा है.
अभी आ रहा है. Okay. So I repeat, acid-base titrations are the titrations in which you titrate an acid against a base or a base against an acid. And the indicators used for acid-base titration are phenolphthalein. You can use methyl orange, methyl red, thymophthalate, depending upon the pKa value of the indicator and pH of your solution at the equivalence point. This you have studied in your SY. You can't use phenolphthalein in all acid-base titration. There are conditions. If the pH at the equivalence point is compared with the pKa value of the indicator, and then only you can select phenolphthalein. Or you will have to take methyl red, methyl orange. I hope this is clear. I repeat, acid titration in which acid is titrated against a base, or a base is titrated against an acid is acid-base titration. And indicators use are phenolphthalein, methyl red, methyl orange, hemophthalate. Depending upon the conditions, you have to select an indicator. Now we will see what are complexometric titrations. Okay, very interesting complexometric titration. Now see, I think my board is visible to all. Complexometric titration. Aarti Gupta left and she's coming. 1 minute. Let me see. Yeah, complexometric titrations are the titrations in which soluble undissociated complexes form when you add a titrant to the sample solution. Means what? When you add a titrant means a burette solution into a conical flask, a complex should be formed, and a complex should be in the soluble form. So the definition goes, 1 minute, I don't have to. Let me see, मेरा board पूरा visible. Yes, can you see what is written on the board if I keep it at this distance? Karthik,
मॅम अजून थोडं बाकी आहे.
करू पण are my alphabet visible?
येस मॅम. हो मॅम.
हाँ हाँ, दिख रहा है ना? Yeah, is it visible? What is this complexometric titration? What I have written is visible?
येस मॅम.
Okay, thank you. So now listen. Now I can view the full board at a glance. So complexometric titrations are titrations in which a soluble undissociated complex is formed during the addition of titrant to your sample solution. Means when you titrate, a complex should be formed. The complex should be soluble form, and the complex should not dissociate. So I repeat, complexometric titrations are titrations in which soluble, undissociated complex is formed. I repeat, when you titrate, you will do this titration in your lab. When you titrate, the complex will be in the soluble form. You will not see a precipitate sort of thing. Things will be transparent in your conical flask. So I repeat, complexometric titrations are the titrations in which the soluble undissociated complex is formed during the addition of titrant. What is titrant? Wait, let me ask someone. What is a titrant? 1 minute. I'll go down first. What is a titrant? Yes, Vikas, unmute. What is a titrant? Vikas Gupta. What is a titrant? Titrant is a solution which is filled in the burette, is added to the sample solution. Now what happens is the complexing agent used commonly is EDTA, which we have done in titration. Talcum powder, I think we have taken EDTA, and I told you that time I will explain what is EDTA in the theory lecture. Okay. So burette solution, that is complexing agent, is EDTA, ethylene diamine tetraacetic acid, and the sample solution is a metal ion solution. Suppose I take copper sulfate solution in conical tab, means I am having a copper metal ion solution in conical flask. Now who will tell me? Wait, Vikas never came in. Vikas, are you there? Unmute karo fatafat. Vikas?
Yes, ma'am.
Yes, tell me,
Yes,
what
ma'am.
are complexometric titrations? What are complexometric titrations?
पता
In
नहीं.
simple words, you can say complexometric titrations are titration in which a complex is formed. Vaishnavi, please repeat. What are complexometric titrations?
Soluble undissociated complex is formed during addition of titrant to the sample solution.
Wait, Vaishnavi. Now, what is a titrant?
Titrant is a burette solution.
Very good. So, in simple words, you can say, very good, Vaishnavi. Mute yourself. So complexometric in which a complex is formed, but complex should be in soluble form. That is when you titrate, it should be soluble form and it should not dissociate. So the definition goes, complexometric titrations are titration in which soluble, undissociated complex is formed during the addition of titrant burette solution to your sample solution. Now the complexing agent, that is the titrant most commonly used, is EDTA, and the sample solution is metal ion. Metal ion म्हणजे काय? Iron. Iron you have to dissolve it in some HCl solution or some acid, and you have to make it in soluble form. See, when you say metal ion solution, you are worried. अरे iron कैसे लेंगे? Copper कैसे लेंगे? Copper means you take copper, dissolve it in some acid, and then you take them. Is it clear? So that is your metal ion solution. Who will tell me? Wait, Vaishnavi के पहले कौन है? Suchita, unmute. Suchita, please unmute.
Yes.
Yes. Now tell me, metal ion solution म्हणजे काय? What are metal ion solutions? Example.
Mm,
Suchita, please listen, be attentive. Metal ion means, suppose I am taking a
Copper.
copper sulfate solution, means I am taking a copper metal ion solution. If I am taking iron solution from the corner, pipetting iron solution means I am titrating iron metal ion solution against EDTA. Okay, so these are complexometric titration, simple word type formation of complex when you add a complexing agent to the metal ion solution. So whenever in your chemistry, post-graduation or research, if you have to titrate metal ion, what will be the type of titration? It will be complexometric titration. If you want to titrate an acid against base, it will be acid-base titration. Okay, now very important, we will talk about this EDTA. See, EDTA is generally filled, mostly filled in is used as a titrant and it is a complexing agent. बराबर है? Complexing agent. So formula for EDTA is ethylene diamine tetraacetic acid. Acetic acid का formula, Vaishnavi, tell me what is the formula for acetic acid?
CH3COOH.
Yes, CH3COOH. Very good. I find this math basic is slightly clear. So now see, acetic acid formula is CH3COOH. When you remove one H plus from there, it becomes get attached to this amino group. So the full form of ethylene diamine tetraacetic acid. This is ethylene group CH2 CH2. I hope you can understand this. This is the ethylene diamine tetraacetic acid. The four CH3 molecules get attached to NH2 by losing one H plus. Okay. So the formula is ethylene diamine tetraacetic acid in your viva for talcum powder. Examiner will keep one thing for and they will tell write the formula for ethylene diamine tetraacetic acid. This topic is there in theory, but still 80% students are not able to write the formula. Is it so difficult? Look at the structure. Ethylene diamine tetraacetic acid. Acetic acid is CH3COOH. So when it attaches to amino group, it becomes CH2COOH. It is so easy. Okay, is this much part clear? Now listen. This ethylene diamine acetic acid, when it coordinates to your metal ion, it will coordinate through these two nitrogen बराबर है and it will coordinate through your 1 minute. 1 minute. It will coordinate through four oxygen atoms. So when this proton goes, this becomes negative, this becomes negative, and this becomes negative. So what happens? This ethylene diamine will coordinate through two nitrogen atoms and four oxygen atoms of ethylene diamine tetraacetic acid. Therefore, ethylene diamine tetraacetic acid is called as hexadentate ligand. Now fill in the blanks. Three fill in the blanks are there in this. I'll ask. Ethylene diamine acetic acid coordinates to dash atoms. Wait, who will answer? Sujit Misal was late in entering today. Soni Yadav, unmute and tell me. Soni, Soni, please unmute.
Yes, ma'am.
Yes. So ethylene diamine tetraacetic acid coordinates two metal ions through dash atom, dash number of atoms. How many atoms? How many atoms? See, this ethylene diamine will form complex with metal ion by coordinating through how many atoms? Through how many atoms?
Ma'am,
Yes.
four oxygen.
No, it will coordinate through Akansha. Tell.
Ma'am, nitrogen.
Now it will coordinate through dash number of atoms. It will coordinate through six atoms. How these two nitrogen atoms and these four oxygen atoms. This is the first objective question. Sony, please repeat. Ethylene diamine will coordinate to metal
Yes,
ion
ma'am.
through dash number of atoms. How many atoms
Six,
it will? Huh?
six item.
Six. What are
Yes.
those? What which atoms?
Ma'am, CH2, CH2, and NN.
No, no, it will coordinate only to two nitrogen atoms and four oxygen atoms. That is why we say it coordinates to the metal ion through six atoms. Okay, now next question
Yes,
is
ma'am.
slightly tricky. Yes, Sakshi, you tell me now. Sakshi, unmute. Yes,
Yes, ma'am.
ethylene diamine will coordinate through metal ion through dash number of nitrogen atoms. What will be the answer?
Ma'am, two number of nitrogen
Very
atom.
good. So whenever you are asked objective question, you should read how many number of nitrogen atoms? Two. Now Sai, you unmute. Sai, unmute. Yes, it will coordinate to dash number of oxygen atoms. How many oxygen atoms? Four oxygen atoms. So there are three objective questions. See, there will be three papers. One they will ask is coordinate to metal ions with dash number of atoms. You will write six. Dash number of nitrogen atoms. You will write only two. Dash number of oxygen atoms. You will write four oxygen atoms. Is this much part clear? I think so. It is clear. So I proceed. Now the next important part which they have written is the no, now wait. Before that, see every time in the reaction to write this big structure is very difficult. So what they have done, this full structure you can write it in the form of H4Y. If I write H4Y means it is EDTA. It has got four hydrogen atoms which can be dissociated. Clear? Instead of writing full formula every time, I will only write H4Y. It means EDTA. But this EDTA is sparingly soluble in water. Sparingly soluble. So you cannot use it as a titrant. You cannot use EDTA because it is not soluble and you cannot fill the burette with a turbid solution. Now, let me tell you for titrimetry, any titration solution should be transparent. It can be colored. Yellow color hone do, purple, but it should be transparent. But EDTA is not properly soluble in water. It is sparingly soluble. So instead of EDTA, we take sodium salt of EDTA, Na2H2Y. Okay, so what is Na2H2Y? It is a sodium salt of EDTA. And this sodium salt of EDTA is soluble in water. Please remember, all sodium and potassium salts are water soluble. I have told you, wherever you do research, and you have got something which is not soluble, convert it into its sodium form, convert it into its potassium form, it will be soluble in water. Okay, so all sodium and potassium salts are soluble. So since EDTA is insoluble in water, we use sodium salt of EDTA. So what happens? This also can be written as H2Y2 minus. Now tell me, if I write H2Y2 minus, what does it mean? Sagar ka number aana. Yes, Sagar unmute. Where is
Yes,
Sagar?
ma'am.
Yes, tell me.
Yes, ma'am.
If I write H2Y2 minus, what does it mean? H2Y2 minus, if I write, what is it? Okay, Sagar, we'll go back again. Tell me, what is H4Y?
EDTA.
Yes, full EDTA, instead of writing
Yes.
this big structure, I will write it as H4Y because it has got four hydrogen atoms which can be dissociated. And but then
Yes,
is
ma'am.
EDTA sparingly soluble in water?
No, ma'am.
Is it soluble in water? No. So
No.
we use a sodium salt of EDTA. What is the formula for sodium salt of EDTA?
Na2H2Y.
It is disodium salt of EDTA. And this I can also write as H2Y2 minus. So if I write H2Y2 minus means it is a disodium salt of EDTA. Is this first part very clear?
Yes,
Any
miss.
doubts in here? Please tell me. I'm going to rub this part now. Any doubts up till here? Now I'm going to discuss a very important part. If you understand, it is fine. Or you just remember one statement
मॅम
that will. Yes, Kone Natasha, tell me.
मॅम ते वाय म्हणजे काय इंडिकेट करतं?
Y means H. 4H सोडून जो भी मोठा structure है, it is represented by Y. To write a big structure of EDTA is difficult. So what they have written, every reaction मध्ये तुम्ही एवढं मोठं reaction plus sodium giving out this घेणं is difficult. So what they have written, they have removed 4H plus H4Y. Y means 4H काढले की उरलेला full structure is your Y. Okay. It is
ओके
just for
मॅम.
the convenience of writing. Okay. Now very important is you should understand this is EDTA, ethylene diamine tetraacetic acid, reacts with all metal ions in ratio of 1 is to 1. This is the best objective question. EDTA reacts with all metal ions in the ratio 1 is to 1 means, suppose I am having zinc or I take bismuth or I take thorium plus 4, anything, divalent, trivalent or thorium, it will react in the ratio of 1 is to 1. And 1 is to 1 and when calculation becomes easy, you can easily write M1V1 is equal to M2V2. Divalent असेल तर तुम्हाला काय लिहायला लागतं M1V1 is equal to 2 M2V2. Isn't it? Trivalent acetylene, what you have to return? Trivalent acetylene, you have to write N1V1 is equal to 3 times N2V2. But N1V1 acetylene, I don't know whether I'll explain that also in the calculation part chapter which we will write. But N1V1 acetylene, so it will always remain N2V2. That I'll teach you. But only listen, understand the concept. EDTA reacts with all metal ions in the ratio 1:1. Means always it will be M1V1 is M2V2. If you have a divalent, trivalent or tetravalent, it will react only in 1:1. See how I will tell you. How to represent. Now what is this H2Y2 minus? Sagar, what is this H2Y2 minus? Sagar, what is H2Y2 minus?
सोडियम
Yes. Sodium
सोडियम
काय?
EDTA म्हणजे ते
Disodium salt of EDTA. Don't say sodium. Sodium is explosive. It reacts with water and air giving heat. Okay. So this is disodium salt of EDTA. General reaction I am showing you now. Plus metal ion. Any metal you take copper, zinc, thorium, bismuth, chromium, anything. It will react to form M by N minus 4 plus 2H plus. Okay. Suppose I take a univalent metal ion. So what will happen? H2Y2 minus plus M plus 1 will give you My. Metal ion ka N is what? Metal ion ka this is plus 1. Plus 1 minus 4 is minus 3. Plus 2H plus. Similarly, if you have H2Y2, if I take a divalent metal ion such as zinc, what will happen? So you get My, N is a 2. See, I am substituting this. This is a general reaction which is derived. Okay. Now, Sagar के पहले कौन है? Preeti. Preeti, tell me. This is disodium salt of EDTA plus M2 plus. Preeti, unmute.
Yes,
Yes.
ma'am.
What will be your My raised to My raised to बोलो N किती आहे इथं डायव्हॅलेंट म्हणजे NH2 बरोबर आहे 2
Yes.
minus 4 कितना आएगा -2 plus 2H plus. Wait, Preeti, you are going to tell me the next. Suppose I take a trivalent metal ion such as bismuth. What will happen? My. Sorry. My. Raised to किती होणार?
-3.
Minus
3.
3 कसं होणार? This is 3. बरोबर आहे? N minus 4. N is what? 3.
Ma'am,
3
minus
minus.
1.
Yes, so it will be,
-1
yeah, 1 minus plus 2H plus. But when suppose I take a tetravalent ion such as thorium, 4 plus, what will be it? My raised to 0 म्हणजे My raised to 1 plus to anything raised to 0 is the same number, okay? म्हणजे 2 raised to 0 is equal to 2. So My raised to 0 येणार ना? So it is same as My plus 2H plus. So you can see this EDTA, 1 minute, 1 minute, 5 minutes. Yeah. So this EDTA, this is sodium salt of EDTA, sodium salt, sodium salt. It reacts with a univalent ion in one place. Either दो लिखा है क्या मैंने 2 metal ions. Have I written here 3 metal ions? No. This is 1 and this is 1. This is 1, this is 1. I don't have a color marker, otherwise it would have. Dekho, 1:1 ratio. A favorite objective question. EDTA reacts with any metal ion in the ratio 1:1. Is this much part clear? Who will tell me? Natasha's number hai. Yes, Natasha, unmute.
Yes, ma'am.
Yeah, EDTA reacts with metal ion in ratio of 1:1, 1:2, 1:3, 1:4. What is the answer? Yes, Natasha. EDTA reacts with metal ion in the ratio of dash. What is the ratio? Unmute कर
Ma'am,
Natasha.
1:1.
1:1. Now tricky question. Next. Namrata, unmute. Namrata, please. Tricky, tell me. EDTA reacts with Zn plus 2 in the ratio of dash. 1:1 to 1:2. I repeat my question. Everyone listen. EDTA reacts with Z and 2 plus in the ratio of 1:1 to 1:2. Yes.
Ma'am, 1:2.
Wrong, Namrata. Wrong.
1:1.
EDTA
1:1.
reacts 1:1. See, EDTA reacts with any metal ion in the ratio of 1:1. You know, when we set papers since 2014 to find the objective question is difficult. So when we sit together, we try to trick the question. Once I asked EDTA reacts with thorium in the ratio of 1:1 to 1:4, and I tell you, most of the Mumbai University students wrote 1:4. It is there where we can differentiate between an above average student and an average student. If you understand this concept, EDTA will react with any metal ion in the ratio of 1:1. And that is the biggest advantage of using EDTA as a titrant. See, it is very difficult for y'all also to grasp in one lecture. I understand. First lecture है वो दिमाग में जाता नहीं है. Thorium plus 4 है और 1:1 में कैसे react होता है. But it reacts in 1:1 ratio. If you study, go detail and see the structure of the complex, you will understand the beauty. It reacts in 1:1. Even if I ask bismuth, it reacts in 1:1. If I ask chromium, it reacts with all metal ion in the ratio of 1:1. State publication के पीछे question है, EDTA reacts with metal ion in the ratio of 1:1. Everyone in Mumbai University say yes, EDTA 1:1. Thorium पूछा तो immediately wrong. Bismuth पूछा तो wrong. You should understand each and every line of the textbook. When you study in the beginning, study with full mind. एक line पूरा understand करो. Next line. Each line has got a significance. Could be line if you don't understand, please clarify immediately. Okay? So this part is over. So the general reaction, whenever you have to write the general reaction, you should write this H2Y2 minus. This is disodium salt of EDTA. Wrong disodium salt of EDTA reacts with metal ions in the ratio of 1:1, and the reaction is H2Y2 minus plus M plus, giving out MY3. This is reverse. Equilibrium maintain करता है, हाँ. So H2Y2 minus plus N plus, giving out MYN minus 4 plus 2H plus. It should attain equilibrium. In some places in textbook they have given a single headed arrow. You write it always double headed. Sodium salt of EDTA reacts with metal ion to form MYN minus 4 plus 2H plus. If you know the reaction, you can write any reaction. Now, very important next point is, since H plus are liberated in the reaction, सब जगह H plus are given out. So what happens? These titrations are pH dependent. You have to adjust the pH properly. We have seen in practical titration of calcium and magnesium in talcum powder. बराबर है, calcium and magnesium we titrated. We adjusted the pH to 10. Alkaline medium में ही calcium and magnesium will form complex with EDTA. So the complexation reaction are pH dependent. That is why I told you that talcum powder you have to evaporate to dryness to remove all HCl. थोड़ा HCl रहेगा, pH will not be 10 and you will not get the correct endpoint. So I repeat, since H plus ions are liberated in the titration, these titrations are pH dependent. Is it clear? Now let me take attendance. 1 minute. For me now attendance has become important. See, this is 1 minute. 1 minute.